In practice exercise 16.19 rotate, we want to write a method rotate that moves the value at the front of our list of integers. We're going to completely take it out and remove and put it at the end. So this example is given to us as a pretty good example of what would happen if list.rotate was called. In list.rotate, you can notice I have this initial if statement here. And this if statement is basically saying if our front value is null, meaning there's nothing there, or if the next value is null, meaning there's nothing there, we're not going to do anything. And that's just because if we only have one value, then we don't need to really rotate. So we can assume that we have at least two values if we are inside of this if statement. Now, what we're going to want to do is store the very first value so that we don't lose it. We can add it back later. We're going to do a list node, and we're going to call this end, and I'm going to set it equal to this dot front. So it's going to get the front, and that's pretty much it, and everything after that actually. So we'll actually have to update the next value. So we'll do end dot next is going to be equal to null. That way it only stores the very front value. After this, what we're going to want to do is take this out of our original list. We can do this by setting this dot front equal to this dot front dot next. Now the very first value is going to be the original next value. So it's going to look like this. Now we just get to add our 8 back in. We're almost done. And the way we can add our 8 back in is we have to go through this entire list. Once we're at the end, we can do the addition back in. So we're going to do while, and we're going to need a new list node for this to run through it. We're going to do list node current is equal to this dot front. So that's going to be equal to this dot front dot next part. And we're going to say while our current does not equal to null, because if our current dot, this should be current dot next, actually, my apologies. We'll do current dot next is not equal to null, because if current dot next is not equal to null, that means we are going to be in the middle somewhere. If current dot next is null, that means we're going to be at this last value, and we want to append our list node end up here. We want to append it to our list. We're going to update our current pointer. Current is equal to current.next, and this is just going to update it down the entire list. Once we're at the end, we can add this. So we're going to say current.next is going to be equal to our end value, and because I set this equal to null up here, it should be fine with us just ending it like this. If not, we might have to set the current next value to null. So that only passed 2 out of 2 tests, and it's because it throws a null pointer exception. Let's try getting rid of this and doing a current.next is equal to null. That might like it a little bit better. We'll see what it thinks. But this is essentially getting the very first node. Okay, and it does like it. This gets the first node. This is going to update our list to a new front. We're going to run through that list and then add this to the very end right here. And I'm assuming the reason why that didn't work is because current, even though list node end has a null pointer value, it has a null value pointing to the next after this end, our current didn't. So when we added it in, it was still waiting for a null value to end that. Let's see if we can actually remove this line, this dot front, take this out and just put the this dot front dot next in here. And this might not work because we're only updating our temporary current list node. We're not updating the entire front of our list. And you can see that why that would not work. So let's go back, just testing things out just to show you more about the list nodes and hopefully you understand it. If you don't understand it, you can always leave the comment below. I'll get back to you on that. If you want more practice, it's in the playlist link below the like button, but that's going to be the solution for 16.19 rotates.